Hello बच्चों, let's read the question. So the question says, two identical buggies 1 and 2 with one man in each moves without friction due to inertia along the parallel rails towards each other. When the buggies get opposite each other, the men exchange their places by jumping in the direction perpendicular to the motion direction. As the consequence, buggy 1 stops and buggy 2 keeps moving in the same direction with its velocity becoming equal to v. Find the initial velocities of the buggies v1 and v2 if the mass of each buggy without a man equals capital M and the mass of each man is small m. So to understand the question better, let us first make a diagram. So let this be our buggy 1. This is our buggy 1. This is buggy 1 and a man is standing on it. Okay, it has mass small m and buggy has mass capital M. It is moving in this direction with velocity v1 and let this be buggy 2. It is in a parallel rail. Let this be buggy 2. It has also a person standing on it with mass small m and this mass is capital M and this is moving in this direction with velocity v2. So we have to find v1 and v2 and we are given that when they cross each other, let's suppose they cross each other at this point. Let this be buggy 1 and this is buggy 2. Both of the men, let this be buggy 2. Both of the men exchange their places. Now this is man, let this be man 1 and this be man 2. So man 2 comes here and here is man 1. Okay, so the initial velocity of man 2 was also v2 and initial velocity of man 1 was also v1. Now their final velocity becomes 0 and its final velocity becomes v, let's suppose. So now buggy 1 stops. Okay, it is correct. Now let us write the key concept behind this question. Let us first revise it. Key concept. So the key concepts behind this question is conservation of linear momentum. So why can we apply conservation of linear momentum here? Because there is no net external force. So when delta F external is equal to 0, we can apply conservation of linear momentum. So using conservation of linear momentum, we can proceed to our solution. So let's check. Let's first conserve the momentum for buggy 1 and person 2. So for buggy 1 and person 2, buggy 1's initial momentum was capital mv1 and the person 2's initial momentum was small m into v2 with a negative sign because v2 was in negative direction. So this is the initial momentum of buggy 1 and person 2. So it must be equal to the net final momentum, which comes out to be equal to m plus small m into final velocity, which is 0. So this is the first equation we get, which is mv1 minus small mv2 is equal to 0. Let's mark it as equation 1. Now let's this is final momentum. So now let's conserve it for buggy 2 and person 2. Buggy 2 and person 1, sorry. So for buggy 2 we have capital M and minus V2 because negative sign comes, it is in opposite direction, plus small m into V1, small m into V1. It will be equal to final momentum, which is equal to capital M plus small m times V, small v. So let us write it as equation 2. Now our final goal is to solve these two equations and find the value of V1 and V2. Proceeding to our next part of solution, from let's suppose from equation 1 we find the value of V1. So V1 will be equal to small m V2 over capital M. So putting this in equation 2, what do we get? We get the value of it will be equal to minus m V2 plus small m into mv2 over capital M. It will be equal to capital M plus small m times V. From here we can find the value of V2. Let's take V2 common. So taking V2 common, we get m square minus m square upon capital M. It will be equal to m plus m times V. Now solving it, we get V2 will be equal to m plus m times small v over writing small m square minus capital M square is equal to m plus m into m minus m and into capital M. So m plus m cancels each other out. We get the value of V2 is equal to capital MV over capital M minus small m. So this is the initial velocity of buggy 2, and putting this in equation 1 we can find the velocity of buggy 1. So putting this in equation 1, what do we get? We get capital MV1 minus small m times V2 is equal to capital MV over m minus m will be equal to 0. So solving it, we get m square V1 minus capital M small m V1 minus capital M small m V. It will be equal to 0. From here we get value of V1 into m square minus m. It will be equal to v. So from here we get V1 is equal to m small m V over m comes common, it will be equal to m minus small m. So m cancels each other out. We get its value to be mv over capital M minus small m. So this is the value of V1 comes out to be mv over capital M minus small m. So we have found out both the initial velocities. I hope you understood it well. Thank you.